The sun, our brilliant blazing neighbour in the sky, shines down on us every day, powering life, shaping weather, and inspiring wonder. But behind that familiar glow lies a star full of surprises, mysteries, and cosmic drama. From raging solar storms to ancient myths, the sun's story is far more fascinating than just daylight. Join us as we explore 100 incredible facts about the star that makes life on Earth possible, and uncover secrets you've never noticed in its radiant light. Fact 1. What is the sun? Have you ever stopped to think about the giant ball of fire hanging in our sky every day? That's the sun. And it's not just a bright light to warm your mornings, it's a massive star, the heart of our solar system. Imagine it as the ultimate power source, a glowing furnace so huge and energetic that everything around it, including us, relies on it. Without it, life on Earth would simply vanish. So, what exactly is the sun? At its core, it's a ball of gas, mostly hydrogen and helium, churning with unimaginable heat and pressure. Deep inside, a process called nuclear fusion is constantly happening. In simple terms, hydrogen atoms are squished together to form helium, and this tiny bit of fusion releases an enormous amount of energy. Energy that eventually reaches Earth as sunlight. That's the light we see, and the warmth we feel. But here's the thing, the sun isn't solid like a rock. You can't stand on it, and you definitely don't want to try. It's a boiling, swirling sphere of plasma, constantly moving and shifting. Sunspots appear here and there, cooler patches on the surface, while massive eruptions can shoot out streams of particles into space. Even from millions of miles away, we can see and feel its influence every day. And here's a fun mental trick. Even though it seems small in the sky, that tiny circle is actually a monstrous ball that defines our solar system. It's not just a star, it's the star that everything orbits. So next time you see the sun rising, think about it as the beating heart of a vast cosmic neighbourhood, tirelessly sending energy across space to make life possible. Fact 2. The sun as a star in our galaxy. It's easy to think the sun is unique. After all, it's the one we see every day. But it's actually just one of hundreds of billions of stars in our galaxy, the Milky Way. That's right. Our sun is a pretty ordinary star, a middle-aged yellow dwarf, but it plays a starring role in our corner of space. Stars like the sun are scattered across the galaxy, each with its own planets, dust clouds, and magnetic activity. But compared to some other stars, the sun is, well, calm. There are stars hundreds of times larger and thousands of times hotter, and there are some so tiny and dim you'd need a telescope just to spot them. In fact, most stars in the Milky Way are smaller red dwarfs, quietly burning for billions of years. Our sun's position in the Milky Way is also pretty special. It sits about 27,000 light-years from the galactic centre, comfortably orbiting around it once every 250 million years. Imagine that, a complete cosmic lap around the heart of our galaxy. And even though it's just one of billions of stars, without it, our solar system wouldn't exist, and we wouldn't be here to wonder about the galaxy at all. So, while the sun is ordinary on a galactic scale, for us, it's everything. It's the constant in a universe full of chaos, a glowing reminder that even ordinary things can be extraordinary, depending on perspective. Fact 3. Distance from Earth. We all know the sun feels close. Its warmth hits our skin every day. But in reality, it's about 93 million miles away from Earth. That's 150 million kilometers if you prefer. To put that into perspective, if you drove a car to the sun at 60 miles per hour without stopping, it would take over 200 years to get there. Even though it's so far away, sunlight still reaches us in about 8 minutes. Every time you step outside on a sunny day, you're literally seeing a snapshot of the sun as it was 8 minutes ago. And this distance isn't just a random number, it's perfect. Close enough to keep our planet warm and support life. Far enough to avoid frying everything instantly. This distance is also why the sun looks so small from Earth, even though it's gigantic. Its rays spread out over millions of miles, which is why solar energy feels gentle and life-sustaining instead of deadly. In short, the sun's distance is the Goldilocks zone for Earth. Not too hot, not too cold, just right. Fact 4. The sun's size. Compared to Earth, here's a mind-blowing fact. The Sun is enormous compared to Earth. In fact, you could fit about 1.3 million Earths inside the Sun. Try picturing that for a second. That tiny blue dot we call home, just a speck inside this gigantic glowing ball. The Sun's diameter is roughly 864,000 miles, 1.39 million kilometers. That's 109 times wider than Earth. And its volume is so immense that the planets of our solar system could fit inside it with room to spare. Yet, despite its size, the Sun isn't solid. It's a seething ball of plasma, with gases constantly moving, rising and falling in convection currents. Size matters for more than just wow factor. Its sheer mass and gravity hold the planets in orbit and control the dynamics of the entire solar system. Everything, Mercury, Venus, Earth, even distant Neptune, obeys the Sun's gravitational pull. It's like the invisible hand keeping our cosmic neighborhood in order. Fact 5. The Sun's mass and gravity. Speaking of gravity, the Sun is ridiculously massive. It contains more than 99.8% of all the mass in the solar system. That's right. All the planets, moons, asteroids and comets combined barely tip the scale compared to the Sun. Its mass is about 2×10^30 kilograms, an almost unimaginable number. This mass is why the Sun's gravity is so strong. It's what keeps Earth and the other planets locked in their orbits. Without it, planets would drift off into space, and the delicate balance that allows life to exist here would collapse. Even comets and asteroids feel its pull, which is why some swing close to the Sun before being flung out again. The Sun's gravity also influences its own behavior. Its enormous mass compresses the core, creating the extreme pressures needed for nuclear fusion. Every photon of sunlight that reaches Earth began life under these crushing conditions, making the Sun not just big but powerful in every sense. Fact 6. Composition, hydrogen and helium. When you look at the Sun, it might seem like a simple ball of light in the sky. But inside, it's basically a cosmic cocktail, mainly hydrogen and helium. Imagine this. About 74% of the Sun's mass is hydrogen, and around 24% is helium, with the remaining 2% made up of heavier elements like oxygen, carbon and iron. It's mostly gas, not solid, not liquid, just an incredibly hot, dense plasma swirling in a constant dance. Hydrogen is the key ingredient here. It's the fuel that keeps the Sun shining, powering everything from sunrise to sunsets. Deep in the Sun's core, hydrogen atoms are being squeezed together in a process that creates helium, and, as a byproduct, the sunlight and warmth we feel on Earth. Helium, meanwhile, is like the Sun's leftovers from this nuclear cooking process. Over time, more and more hydrogen is converted into helium, changing the Sun's internal makeup little by little. Think of it like a cosmic engine running on hydrogen fuel. Every photon of sunlight that reaches you started its life as part of this hydrogen-helium fusion dance. Without this mix, our solar system would be a dark, frozen wasteland, and we'd be nowhere to marvel at the sky. Fact 7. Core temperature of the Sun. Here's where things get intense. The Sun's core is unimaginably hot. We're talking about 27 million degrees Fahrenheit, 15 million degrees Celsius. That's not just hot. It's a heat so extreme that no material on Earth could survive it, not even in your wildest sci-fi imagination. This insane temperature is crucial because it creates the conditions for nuclear fusion. Under this pressure and heat, hydrogen atoms collide and fuse into helium, releasing a tremendous amount of energy. Every second, the Sun fuses around 600 million tons of hydrogen, producing energy that powers the solar system. That's enough energy to light billions of cities for billions of years. Interestingly, despite this heat, the energy takes thousands of years to reach the surface. Photons bounce around in the dense core and radiative zone, zigzagging in a chaotic journey, before finally escaping as sunlight. So when you step outside and feel the Sun's warmth, you're enjoying energy that started its journey deep in the core, possibly millennia ago. Fact 8. Surface temperature of the Sun. While the core is scorching hot, the Sun's surface, known as the photosphere, is cooler, relatively speaking. The temperature here hovers around 10,000 degrees Fahrenheit, 5,500 degrees Celsius. That's still ridiculously hot compared to Earth standards, but it's what makes the Sun appear yellowish to our eyes. This surface temperature creates the light and heat we experience daily. It's also responsible for visible features like sunspots, which appear darker because they are slightly cooler than the surrounding areas. The sun's surface isn't still either. It roils with convection currents, plasma bubbling up and down, giving it a constantly shifting, almost alive appearance. So next time you see sunlight streaming through your window, remember it's coming from this fiery, dynamic surface, a constant dance of energy and movement millions of miles away. Fact 9. How the sun produces energy: nuclear fusion. Here's the heart of the sun's magic: nuclear fusion. Think of it as the ultimate atomic handshake, where hydrogen atoms squeeze together under extreme heat and pressure to form helium. And with this cosmic handshake, energy explodes outward. This energy eventually becomes the sunlight, warmth, and even solar winds that shape life on Earth. Every second, the sun fuses hundreds of millions of tons of hydrogen. The energy released per second is mind-boggling. It's about 384.6 billion trillion megawatts. That's enough to supply every human on Earth with infinite energy for life itself. Fusion is what makes stars shine. Without it, our sun would be just another cold lump floating in space. It's fascinating to think that the gentle sunlight on your face is the product of countless nuclear reactions happening millions of miles away. And that energy, once born in the core, takes thousands of years to finally escape to the surface before travelling 8 minutes through space to reach us. Fact 10. The sun's age and lifespan. The sun is a middle-aged star, about 4.6 billion years old. To put that into perspective, Earth itself is almost the same age. Scientists estimate that the sun has enough fuel to keep shining for roughly another 5 billion years, which means we're currently in its prime years. As the sun ages, it's slowly turning hydrogen into helium, changing its composition, and eventually preparing for a dramatic future. In about 5 billion years, it will expand into a red giant, possibly engulfing Mercury, Venus, and maybe even Earth, before shrinking down to a white dwarf. It's incredible to realize that the energy that warms us today is part of a life cycle that spans billions of years, a story written in light and fire. Right now, though, the sun is stable and perfectly balanced, giving us enough time to marvel at its brilliance, harness its energy, and ponder our place in the solar system. It's the quiet, dependable hero of our cosmic story, shining every day without fail. Fact 11. The sun's core. Explained. Let's take a journey deep inside the sun, all the way to its core. Imagine travelling millions of miles into a place so dense and hot that nothing we know could survive. That's where all the sun's magic happens. The core is the sun's powerhouse, the centre where temperatures reach around 27 million degrees Fahrenheit, and pressures are so intense that atoms are squeezed together in a process called nuclear fusion. This isn't just some scientific jargon. The core is literally producing the energy that keeps Earth alive. Every second, it fuses about 600 million tons of hydrogen into helium. The energy released in this process is what eventually becomes sunlight, heat, and even the solar wind that streams through space. It's amazing to think that photons from the core take thousands, sometimes even millions of years to reach the surface before finally streaming to Earth in about 8 minutes. The core is also responsible for the sun's stability. It's a delicate balance. The outward pressure from fusion pushes against the inward pull of gravity. Without this balance, the sun could collapse or explode. The core, in a way, is like the engine of a massive spaceship, quietly working day and night, powering a system of planets, moons, and life forms far beyond its reach. Fact 12. The radiative zone. Just outside the core lies the radiative zone, a layer that acts like a gigantic cosmic traffic jam for photons. Imagine energy created in the core trying to escape, but getting constantly bounced around by atoms in the dense gas. This is what happens in the radiative zone. A single photon can take thousands of years to slowly inch its way outward. It's kind of like trying to move through a crowded concert, jostled from person to person, taking forever to reach the exit. That's the sun's radiative zone in a nutshell. And while we might think the energy should rush straight out, this slow, painstaking journey actually plays a huge role in the sun's life, helping regulate temperature and maintain the star's delicate balance. This zone stretches from about 25% of the sun's radius out to 70%, acting as a buffer between the furious core and the more turbulent outer layers. It's a reminder that even in the heart of something as massive as the Sun, patience is a part of the process. Fact 13. The convective zone. After the radiative zone comes the convective zone, where energy finally gets to move more freely, but in a chaotic, bubbling way. Think of a pot of boiling water. Hot plasma rises toward the surface, cools, and sinks back down in giant loops. This constant motion transfers heat outward efficiently and gives the Sun its dynamic, constantly shifting personality. These convection currents also help generate the Sun's magnetic fields, which play a major role in sunspots, solar flares, and even space weather that can affect Earth. The convective zone is essentially where the Sun's surface activity starts to take shape, bubbling and swirling before finally breaking through to the photosphere, the layer we actually see. It's fascinating to realize that the sunlight and warmth we feel is the result of billions of rising and sinking loops of plasma, all choreographed by physics over thousands of miles. Fact 14. The photosphere, the visible surface. Now we've arrived at the Sun's photosphere, the layer we perceive as the Sun's surface. At about 5,500 degrees Celsius, 10,000 degrees Fahrenheit, it's cooler than the core but still incredibly hot by earthly standards. This is the layer from which sunlight escapes, creating the yellowish glow we see in the sky. Despite being a surface, the photosphere isn't solid. It's a thin layer of gas, roughly 300 miles thick, and it's constantly in motion. Granules, small bubbling features caused by convection below, appear and vanish every few minutes. Sunspots sometimes break this smoothness, appearing as cooler, darker patches. When we look at the Sun through special filters, the photosphere reveals an incredibly dynamic, almost alive surface. Every ray of sunlight you enjoy started here, making the photosphere one of the most important layers for life on Earth. Without it, we wouldn't have visible light, warmth, or the ability to observe our star at all. Fact 15. Sunspots. Dark spots on the Sun. Have you ever seen a photo of the Sun with dark blotches? Those are sunspots, and they're fascinating windows into solar activity. Sunspots are cooler areas on the Sun's surface caused by intense magnetic activity, which slows down the normal flow of heat from the interior. Even though they're cooler, they're still incredibly hot, about 3,500–4,500 degrees Celsius. Sunspots often appear in groups and change size constantly. Some are massive, big enough to swallow Earth several times over. Scientists track them because their number and behavior reveal the Sun's 11-year activity cycle. When sunspots are abundant, the Sun is in a more active phase, producing more flares and solar storms that can even impact Earth's satellites and power grids. Interestingly, these dark spots, though cooler, are essential for understanding the Sun. They remind us that the Sun isn't just a calm, steady ball of light. It's alive, dynamic, and constantly changing. Fact 16. The chromosphere, the Sun's atmosphere. If you thought the Sun ended at the photosphere, think again. Just above that layer lies the chromosphere, a thin, fiery atmosphere that stretches thousands of miles into space. It's harder to see with the naked eye, but during a solar eclipse, it appears as a reddish rim surrounding the Sun, a glowing halo that hints at the turbulence above. The chromosphere is hotter than the photosphere, with temperatures rising from around 4,500 degrees Celsius at the bottom to 20,000 degrees near the top. This strange increase in temperature has puzzled scientists for decades. It's a zone where spicules, tiny jets of gas, shoot upward like energetic fireworks, constantly moving and interacting. Even though it's invisible most of the time, the chromosphere plays a huge role in the Sun's behavior. It's the layer where solar flares often begin, and where energy is transferred outward to the corona, the Sun's outermost atmosphere. Without it, the Sun's surface would feel far less dynamic, and many of the solar phenomena that affect Earth would be completely different. Fact 17. Solar flares and prominences. Now, let's talk about some of the Sun's most dramatic moods. Solar flares and prominences. Imagine the Sun suddenly releasing a massive burst of energy and light. That's a solar flare. A sudden, explosive flash caused by the tangling and snapping of magnetic field lines in the Sun's atmosphere. These flares can release as much energy as billions of nuclear bombs going off at once. Prominences are a bit gentler but still stunning. Picture giant loops of glowing gas arching high above the sun's surface, tethered by magnetic fields. Some are so large they could stretch from Earth to the moon several times over. Prominences can last for days or even weeks, dancing across the sun's atmosphere in mesmerizing arcs. Both solar flares and prominences demonstrate that the sun isn't just a calm, steady ball of light. It's alive, dynamic, and full of surprises. And when these events send energy toward Earth, they can create auroras, disrupt satellites, or even affect our power grids, proof that our star is both beautiful and powerful. Fact 18. The corona, outermost layer. The corona is like the sun's mysterious glowing halo, extending millions of miles into space. Even though it's the outermost layer, it's much hotter than the surface below, reaching up to 3 million degrees Celsius. Crazy, right? Scientists are still figuring out exactly why it's so hot, but it's one of the sun's most intriguing features. The corona is visible during a total solar eclipse as a soft, pearly white crown surrounding the sun. It's tenuous, wispy, and constantly shifting, with loops and streamers shaped by the sun's magnetic field. Even though it looks delicate, the corona is responsible for producing the solar wind, sending charged particles streaming through the solar system. So the next time you see an eclipse photo, take a moment to appreciate this outer atmosphere. It's fragile looking but incredibly influential, shaping the space weather that affects planets, satellites, and even us. Fact 19. Solar wind. Particles streaming into space. Speaking of the corona, it's the birthplace of the solar wind. This is a continuous stream of charged particles, mostly electrons and protons, that the sun shoots into space. It flows outward in every direction at incredible speeds, sometimes reaching over 1 million miles per hour. Solar wind might sound harmless, but it interacts with planets' magnetic fields and atmospheres. On Earth, it creates the auroras, the stunning northern and southern lights. On other planets, it can strip away atmospheres over time, which is part of why Mars is so dry and barren today. Even spacecraft and satellites feel its effects, which is why engineers must design them to survive this constant barrage. The solar wind is a perfect example of how the sun doesn't just sit there shining, it's actively shaping the entire solar system. Fact 20. Coronal mass ejections. Finally, we have coronal mass ejections, or CMEs. Imagine the sun suddenly hurling billions of tons of plasma and magnetic fields into space at incredible speeds. That's a CME, a massive solar eruption capable of affecting Earth's magnetosphere in dramatic ways. When a CME collides with Earth, it can produce breathtaking auroras and, in extreme cases, disrupt satellites, communications, and even power grids. Scientists monitor the sun closely to predict these events, since their effects on technology can be significant. CMEs are the sun's way of reminding us just how energetic it is. While beautiful from afar, up close they're like cosmic fireworks, immense, powerful, and utterly uncontrollable. They show that the sun, though a stable star in many ways, still has moods that ripple across the solar system. Fact 21. How sunlight reaches Earth. Have you ever wondered how sunlight, travelling millions of miles through the vacuum of space, actually reaches your skin? It's kind of amazing when you think about it. Sunlight is made of photons, tiny packets of energy born in the sun's core during nuclear fusion. These photons begin a long, chaotic journey, bouncing around inside the sun's radiative zone for thousands of years before finally escaping the surface. Once free, they speed through space at 186,000 miles per second, the universal speed limit. In just about 8 minutes, the sunlight we see has travelled 93 million miles to reach Earth. That means when you feel the warmth on your face, you're actually feeling energy that started deep inside the sun thousands of years ago. It's a connection across time and space that's hard to wrap your head around, but it's also a perfect reminder of how life on Earth is tied to a star millions of miles away. And it's not just light, it's energy that drives weather, powers photosynthesis, and even affects human mood. That simple beam of sunlight is one of the most vital threads holding our world together. Fact 22. The spectrum of sunlight. Sunlight isn't just one colour or one kind of energy. It's a full spectrum, a mix of many wavelengths that together create the light and heat we experience. Think of it like a rainbow compressed into one brilliant beam. There's visible light, infrared, ultraviolet, and even some radio and X-rays, though our atmosphere blocks most of the dangerous stuff. Each part of the spectrum has its own personality. Visible light is what our eyes perceive as colour. Infrared carries heat. Ultraviolet can cause sunburn. And beyond that, there's energy we can't see, but that scientific instruments can detect. The sun's spectrum is a reminder that what we perceive is just a fraction of its full power. It's also why sunlight can do so many things at once, warming the planet, helping plants grow, and even driving the water cycle. All of it comes packaged in one seemingly simple beam of light, but it's actually a symphony of energy. Fact 23. Visible light and colours. When we talk about visible light, we're talking about the tiny slice of the sun's energy that our eyes can detect. It's the rainbow you see when sunlight passes through a prism. Red, orange, yellow, green, blue, indigo, and violet. These colours aren't just pretty, they actually carry different amounts of energy. Blue and violet light are higher energy, while red is lower. This visible light is essential for life. It's what plants use in photosynthesis to make food. It's also what allows humans and animals to see the world around them. Every sunrise and sunset paints the sky with colour, all because the sun emits this full spectrum of light. And here's a fun detail. The sun itself isn't actually yellow. It appears white from space. The yellow colour we see from Earth comes from our atmosphere scattering shorter wavelengths of blue light. So every time you admire a golden sunrise, remember it's a tiny trick of light and air, making the sun's energy even more magical. Fact 24. Ultraviolet rays. Ultraviolet rays, or UV, are the sun's hidden power. We can't see them, but we feel them. Sometimes a little too much if we get sunburned. UV light carries more energy than visible light, which is why it can damage skin cells or fade fabrics over time. But UV isn't all bad. It helps our bodies produce vitamin D, which is crucial for strong bones and overall health. Scientists also use UV observations to study the sun's activity, like flares and sunspots. And on a cosmic scale, UV light influences the chemistry of our atmosphere and even affects other planets. So while sunscreen is a good idea, UV rays are also a reminder that the sun's energy is complex, sometimes gentle, sometimes powerful, always fascinating. Fact 25. Infrared rays. Infrared rays are the sun's heat signature. Unlike visible light, we can't see infrared, but we can feel it as warmth on our skin. These rays carry energy that keeps Earth's surface warm enough for life, and drives processes like evaporation, wind, and ocean currents. Infrared radiation also allows us to see heat. Scientists use infrared telescopes to study planets, stars, and galaxies far away, detecting energy invisible to the naked eye. On Earth, infrared from the sun powers everything from the water cycle to the growth of crops, making it a silent but essential part of our daily lives. So next time you step outside and feel the sun's warmth, think about infrared rays quietly delivering energy from 93 million miles away. It's the sun's invisible hand shaping life on our planet. Fact 26. How the sun affects Earth's climate. The sun doesn't just give us light and warmth, it's the ultimate climate driver for our planet. Think of it as Earth's giant thermostat. The amount of energy we receive from the sun shapes temperatures, winds, ocean currents, and even rainfall patterns. Without it, our world would be a frozen rock floating through space. But the sun's influence isn't uniform. The equator gets more direct sunlight, so it's hotter, while the poles receive sunlight at a slant, making them colder. Seasonal changes, the tilt of Earth's axis, and the sun's slight variations in output all combine to create climate patterns. Even subtle shifts in solar activity, like sunspot cycles, can slightly influence global temperatures. So when we talk about climate, remember that the sun isn't just a background player, it's the main engine. Every breeze, every wave, and every warm summer day can trace its energy back to our star. It's a reminder of just how connected we are to the sky above. Fact 27. The role of sunlight in photosynthesis. Here's a simple truth. Without the sun, plants wouldn't exist, and without plants, we wouldn't exist either. Photosynthesis is the process where plants capture sunlight and convert it into energy, producing oxygen and glucose. Every leafy tree, blade of grass, and tiny algae is essentially a solar-powered factory. Sunlight provides the energy that splits water molecules and drives the chemical reactions needed to make food. In other words, the energy that powers your breakfast comes from photons traveling 93 million miles through space. It's incredible to think that the sun fuels life in such a literal sense, turning light into sugar, oxygen, and growth. Even beyond food, photosynthesis shapes ecosystems, controls carbon levels, and regulates the air we breathe, so every sunbeam is quietly sustaining life on Earth, one leaf at a time. Fact 28. Solar radiation and health. The sun has a complex relationship with our health. On one hand, sunlight provides vitamin D, which is essential for bones, immunity, and mood. On the other hand, too much exposure to ultraviolet radiation can damage skin cells and increase the risk of skin cancer. Interestingly, sunlight also affects our circadian rhythms, the internal clocks that tell us when to sleep and wake. A morning sunbeam can literally reset your body's timing, making you more alert during the day and helping you sleep at night. Even beyond humans, solar radiation affects other life forms. Animals, plants, and ecosystems have evolved in tune with sunlight, relying on its rhythms and intensity for growth, behavior, and survival. It's a delicate balance. Enough sunlight fuels life, but too much can harm it. Fact 29. Measuring sunlight. Intensity. Scientists don't just guess how much sunlight reaches Earth, they measure it. Instruments called pyranometers track solar irradiance, which is the power of sunlight per square meter. Satellites can measure sunlight across the globe, helping us understand climate patterns, weather, and even solar storms. Measuring sunlight isn't just academic, it's practical. Solar panels rely on precise sunlight data to generate electricity efficiently. Farmers use it to plant crops, and ecologists monitor it to study ecosystems. Even our health is tied to sunlight exposure, so understanding intensity helps people get enough without overdoing it. The sun may feel constant to us, but in reality, its energy output varies slightly over time. Measuring it helps us see those variations, connecting us more closely to the star that powers life itself. Fact 30. How sunlight varies with seasons. Ever noticed how summer days feel brighter and warmer while winter days are short and chilly? That's because of the way sunlight hits Earth. Our planet is tilted at about 23.5 degrees, so during different times of the year, sunlight strikes at different angles. In summer, the sun is higher in the sky, delivering more direct light and energy. In winter, it's lower, spreading its energy over a larger area and giving us weaker warmth. This is why equatorial regions stay warm year-round, while poles experience extreme seasonal swings. Seasonal sunlight changes affect not just temperature, but ecosystems, animal behavior, and human activities. Flowers bloom in spring because days are getting longer, and many animals time reproduction to maximize sunlight and food availability. Even our mood can shift with the seasons, thanks to varying sunlight exposure. The sun's tilt and orbit aren't just cosmic trivia. They're the reason we have seasons, shaping life's rhythms in subtle yet profound ways. Fact 31. The sun's gravitational dominance. Have you ever wondered why all the planets, moons, and even tiny asteroids stay neatly in orbit around the sun instead of drifting off into space? The answer is gravity, and the sun's gravity is the ultimate boss of our solar system. Containing more than 99.8% of the solar system's mass, it acts like an invisible anchor, holding everything in a cosmic dance. The sun's immense gravitational pull isn't just about keeping planets in place, it sets the rhythm of their orbits. Mercury zips around the sun in just 88 days, while distant Neptune takes a whopping 165 years to complete one orbit. Yet both are tied to the sun's gravitational grip. Without it, our orderly solar system would be chaos. Planets could collide, drift away, or worse, spiral into the void. Even small objects, like asteroids or comets, feel this pull. Their paths twist and curve as the sun's gravity guides them through space. Essentially, the sun is the invisible conductor of a vast orchestra, ensuring every celestial body moves in harmony. Fact 32. The sun's effect on planetary orbits. The sun's gravity doesn't just anchor planets, it also shapes the way they move. Planetary orbits are not perfect circles, they're ellipses, slightly stretched or oval-shaped. This is because the gravitational interplay between the Sun and other planets creates subtle tugs, influencing speed and distance. Earth, for instance, moves faster when it's closer to the Sun and slower when it's farther away. Mercury, being so close, races around the Sun, while Neptune, in the outer reaches, takes centuries for a single lap. This orbital variation also affects seasons, climate, and even the length of a year. The Sun's effect extends beyond planets. Asteroids, comets, and dwarf planets all obey its gravitational rules. Their paths curve, twist, and sometimes collide due to this invisible force. Without the Sun's gravitational guidance, our solar system would be unrecognizable, a chaotic mess rather than the precise clockwork we observe today. Fact 33. The asteroid belt and the Sun between Mars and Jupiter lies a region filled with rocky fragments called the asteroid belt. These objects are remnants from the early solar system, and the Sun's gravity plays a crucial role in keeping them from scattering into space or crashing into Earth. The belt isn't solid like in sci-fi movies, it's mostly empty space, with asteroids drifting millions of miles apart. Yet the Sun's pull organises their paths, keeping them orbiting in roughly the same plane. Jupiter's gravity also nudges some asteroids, creating gaps and clusters in the belt, but the Sun's gravitational dominance ensures these rocks don't escape the solar system entirely. In essence, the asteroid belt is a cosmic playground under the Sun's supervision, a region of floating debris held in place by the star's enormous mass. Fact 34. Comets and their path. Around the Sun, comets are like cosmic travellers, streaking through the solar system with tails of glowing gas and dust. Their paths are deeply influenced by the Sun's gravity. As a comet approaches the Sun, the heat causes ice and dust to vaporize, creating the iconic tail that always points away from the Sun due to solar wind and radiation pressure. Some comets have short orbits, returning every few years, while others take centuries or millennia. Regardless of their path, the Sun's gravity guides them like a celestial shepherd, bending their trajectories and sometimes flinging them into deep space or toward the inner solar system. The next time you see a comet streaking across the night sky, remember, it's dancing to the tune of our Sun's gravity, a reminder of the star's reach beyond the planets we usually notice. Fact 35. The Sun and planetary atmospheres. The Sun doesn't just influence orbits, it also shapes the very air around planets. Solar radiation heats atmospheres, drives winds, and even causes molecules to escape into space. Earth's magnetic field protects us, but planets like Mars, with a weaker field, have lost much of their atmosphere over billions of years. Venus, on the other hand, retains a dense, scorching atmosphere thanks to the Sun's heat driving a runaway greenhouse effect. Jupiter's massive size helps hold on to its thick atmosphere despite intense solar radiation. Even distant Neptune and Pluto feel the Sun's faint but measurable influence on their thin gaseous envelopes. In short, the Sun is a life-shaping, climate-controlling, atmosphere-influencing powerhouse. Its energy and gravity reach far beyond its visible light, quietly sculpting the planets in ways we often take for granted. Fact 36. How solar activity affects planets. When we picture the Sun, we often imagine a steady, unchanging ball of light in the sky. In reality, the Sun is alive, dynamic, and full of moods that ripple across the solar system. Its activity, flares, sunspots, and coronal mass ejections, CMEs, can reach far beyond our planet, influencing each world it touches in unique ways. On Earth, solar activity is visible in stunning auroras, the shimmering northern and southern lights, where charged particles collide with the atmosphere. But the Sun's reach goes further. Solar flares and CMEs can interfere with satellites, disrupt GPS systems, and even overload power grids, reminding us that our technological civilization depends on a star millions of miles away. Other planets experience the Sun's moods differently. Mercury, lacking a thick atmosphere or a strong magnetic field, is directly bombarded by solar winds, slowly eroding its surface over billions of years. Mars, with only a weak magnetic field, has seen much of its atmosphere stripped away, turning it into the cold, arid world we know today. Even gas giants like Jupiter aren't immune. Their massive magnetic fields interact with solar particles, generating auroral storms far more intense than Earth's. This dynamic relationship highlights a key truth. Planets aren't isolated. They live in a connected system shaped by their star. The Sun's energy isn't just light and heat, it's a force constantly interacting with planets, influencing atmospheres, weather, and even potential habitability. Observing these effects teaches us how delicate planetary environments are, and how a star's activity shapes the life and evolution of worlds in its orbit. Fact 37. Mercury. Closest to the Sun, Mercury, the solar system's speedster, zips around the Sun in just 88 Earth days, making it the fastest planet in orbit. Being the closest planet to the Sun, Mercury lives in extreme conditions that seem almost alien to us. Daytime temperatures soar to a blistering 800 August is 430 dm, while nights plunge to a freezing 290 dm, 180 dm. With virtually no atmosphere to buffer these swings, the planet experiences dramatic temperature shifts every single day. Solar radiation bombards Mercury's surface relentlessly, and solar winds, streams of charged particles, strike it directly, gradually wearing away its crust over billions of years. Surprisingly, Mercury does have a weak magnetic field, a faint shield against the Sun's assaults, but it's barely enough to stop the most extreme solar events. Mercury's proximity makes it a perfect laboratory for studying the Sun's influence. Its surface shows the direct effects of solar energy, radiation, and gravity. Scientists study Mercury to understand everything from space weather impacts to planetary magnetic fields. Living near the Sun isn't just about warmth. It's a daily struggle for survival under intense energy, gravity, and radiation, making Mercury a remarkable testament to the Sun's power. Fact 38. Venus, extreme greenhouse. Effect. Venus is often called Earth's twin, but looks can be deceiving. While similar in size, Venus's thick carbon dioxide atmosphere traps heat in a runaway greenhouse effect, turning the surface into a furnace. Temperatures reach a scorching 900 degree, 475 degree, hot enough to melt lead. The Sun's energy is magnified by this dense atmosphere, creating a planet where survival as we know it would be impossible. Solar radiation doesn't just heat the surface, it interacts with Venus's clouds, generating violent winds and chemical reactions in the upper atmosphere. Despite being farther from the Sun than Mercury, Venus is hotter, proving that a planet's atmosphere can dramatically change how solar energy is experienced. Venus is a stark reminder of how the Sun's energy, combined with atmospheric composition, can transform a world into an extreme, inhospitable place. Fact 39. Earth's orbit and Sun's influence Earth might seem stable and predictable, but it is in a delicate gravitational dance with the Sun. Gravity keeps us in a nearly circular orbit, giving us the consistent seasons that regulate life, weather, and ecosystems. The tilt of our axis, combined with the Sun's energy, creates the rhythm of spring, summer, fall, and winter. Solar activity subtly influences Earth as well. Variations in the Sun's output, sunspot cycles, and occasional solar storms can affect climate patterns, atmospheric currents, and even the intensity of auroras. The Sun's balance of gravity and energy is crucial. Without it, Earth would be inhospitable. It is both our anchor and our life-giver, orchestrating the flow of days, seasons, and years with silent precision. Fact 40. Mars and solar radiation. Mars is a world sculpted by the Sun, yet lacking the magnetic shield Earth enjoys. Solar radiation directly impacts its thin atmosphere, stripping it away over billions of years. This is one reason why Mars is cold, dry, and unable to sustain liquid water on its surface today. Solar winds also create auroral displays near the poles, visible only through spacecraft instruments, offering a glimpse of the Sun's influence in action. Even at a distance of 142 million miles, 228 million kilometers, the Sun shapes Mars' climate, atmospheric loss, and potential habitability. The Sun reminds us that even far-off planets feel the reach of its power, highlighting the interconnectedness of the solar system. Fact 41. Sunspot cycles. Sunspots might look like small, dark blemishes on the Sun's blazing surface, but they are far more than cosmetic imperfections. These cooler, darker areas are actually windows into the sun's magnetic activity, revealing the hidden rhythms and behaviours of our star. Despite appearing calm and constant from Earth, the sun is incredibly dynamic, and sunspots provide one of the clearest indicators of that motion. Sunspots follow a fascinating rhythm known as the sunspot cycle, lasting roughly 11 years. During this cycle, the number of sunspots gradually increases, peaks, and then declines. The peak, known as the solar maximum, can feature hundreds of sunspots, while the solar minimum sees far fewer. Scientists have tracked these cycles for centuries, using them to understand the sun's magnetic field, predict solar activity, and anticipate events that could affect Earth. But why do sunspots matter to us? Beyond their scientific value, sunspots influence space weather and even Earth's environment. High sunspot activity correlates with increased solar flares and coronal mass ejections, which can send radiation and charged particles toward our planet. These events can disrupt satellite operations, communication systems, and even power grids. Some studies suggest they may subtly influence climate patterns as well. You could think of sunspots as the sun's mood swings. They're a visible reminder that our star isn't a constant, unchanging presence. Instead, it experiences cycles of activity and calm, with peaks and valleys that ripple across the solar system. Observing sunspots allows scientists to anticipate changes in solar behaviour and better protect our technology-dependent society. Historical records even suggest that prolonged periods of low sunspot activity, like the Maunder minimum in the 17th century, coincided with cooler climates on Earth, such as the Little Ice Age. This demonstrates just how connected our planet is to the activity of the sun, even in ways we're still learning to fully understand. In short, sunspots aren't just dark spots. They're signs of a star alive with energy and magnetic tension. By tracking them, we gain insight into the cycles that govern the sun, the storms it sends our way, and the broader cosmic forces that shape life on Earth. So, the next time you see a picture of sunspots, remember, these tiny shadows on the sun are actually a window into its heartbeat, showing us the rhythms of a star that drives so much of our daily existence. Fact 42. Solar maximum and minimum. The sun has moods, and they come in cycles. The solar maximum is the sun's energetic peak, a period when sunspots flourish, solar flares erupt, and coronal mass ejections increase. It's as if the sun is at its most lively, almost restless, releasing bursts of energy that can ripple across the solar system. During these times, space weather intensifies, causing dazzling auroras near Earth's poles, and sometimes even interfering with satellites, GPS systems, and power grids. In contrast, the solar minimum is the sun's calmer phase. Fewer sunspots appear, solar flares are less frequent, and the star's overall magnetic activity drops. It doesn't stop shining, of course. The sun still provides warmth and light, but its behaviour is less chaotic, giving Earth's magnetosphere and satellites a relative break from intense solar storms. These cycles are far more than scientific curiosities. Understanding the solar maximum and minimum helps scientists anticipate and prepare for space weather that could impact modern technology. For example, during a strong solar maximum, operators may need to protect satellites or power grids from geomagnetic storms, while astronauts must consider radiation exposure in space. The solar cycle is also a reminder that the sun, which appears so steady to the naked eye, is a dynamic and ever-changing star. Its moods influence not only space but sometimes subtle processes on Earth, like atmospheric circulation patterns and climate variability. Observing these cycles helps us better understand our star, predict its behaviour, and appreciate its influence beyond the light and warmth we receive every day. Fact 43. Solar flares and space. Weather solar flares are sudden, explosive bursts of energy from the sun's atmosphere, like the star momentarily letting out a tremendous scream. These flares occur when magnetic energy built up in the sun's atmosphere is released, sending radiation and charged particles hurtling through space. If Earth happens to be in the path of these flares, we experience their effects as part of what scientists call space weather. Space weather is more than just a curious phenomenon. It has real-world impacts. Solar flares can disrupt radio communications, interfere with GPS signals, and even induce currents in electrical grids, sometimes causing blackouts. Yet space weather isn't only a threat, it also produces breathtaking natural phenomena. When charged particles collide with Earth's atmosphere, they create dazzling auroras, the northern and southern lights. Scientists monitor solar flares closely, using satellites and observatories to detect them as early as possible. Predicting when and where flares will occur is crucial for protecting technology, astronauts, and even power infrastructure. Solar flares serve as a reminder that Earth exists in a dynamic environment, connected to a star that is constantly active and unpredictable. Fact 44. Aurora Borealis and Aurora Australis. Auroras, the Aurora Borealis in the north and the Aurora Australis in the south, are among the most spectacular gifts the Sun offers Earth. These dancing lights appear near the poles when charged particles from the Sun collide with gases in Earth's atmosphere, exciting atoms and creating colourful displays of green, red, purple, and sometimes blue light. Auroras are often more visible during solar maximum or after strong solar flares, making them closely linked to the Sun's moods. Seeing an aurora is like witnessing the Sun's energy travelling across millions of miles, colliding with our atmosphere and painting the sky with colour. They're not just beautiful, they also remind us that the Sun's influence extends far beyond warmth and daylight. The Sun shapes the skies, the magnetic environment, and even human curiosity about the cosmos. Standing under an aurora is like standing directly under a star's fingerprint, a visible connection to the energy and power of our nearest star. Fact 45. Coronal holes. Coronal holes are darker areas in the Sun's outer atmosphere, the corona, where magnetic field lines open into space. Through these openings, high-speed solar wind streams escape, travelling millions of miles and sometimes reaching Earth. When they interact with our planet's magnetic field, they can enhance auroras and even cause geomagnetic storms. Unlike solar flares, which are sudden and unpredictable, coronal holes are long-lived and somewhat more predictable, lasting weeks or months. They demonstrate that the Sun isn't static. Even invisible features like coronal holes have tangible effects on Earth. High-speed winds from these holes can interfere with satellites and power grids, reminding us that our technological civilization exists in a direct relationship with a dynamic star. Even though coronal holes are invisible to the naked eye, they play a real role in shaping space weather, auroras, and Earth's magnetic environment. They are another example of how closely our planet is connected to the Sun's ever-changing activity, showing that the star we take for granted is constantly influencing life and technology on Earth. Fact 46. Magnetic fields of the Sun. The Sun isn't just a ball of hot gas, it's a giant magnetic dynamo. Its magnetic fields are invisible, yet they shape almost everything we see on the Sun's surface and atmosphere. Sunspots, solar flares, and coronal loops all trace the twisting, shifting magnetic lines generated deep inside the Sun. These magnetic fields are created by the movement of charged particles in the Sun's interior, particularly in the convective zone. As plasma rises and falls, it drags magnetic lines with it, stretching and tangling them. Sometimes these lines snap, releasing energy as a solar flare. Other times they form loops or prominences, towering thousands of miles above the surface. The Sun's magnetic fields are constantly changing, reversing approximately every 11 years along with the sunspot cycle. They control space weather, influence planetary atmospheres, and even shape the solar wind. Essentially, the Sun's magnetic personality is as important as its heat and light in shaping the solar system. Fact 47. Solar storms and Earth's magnetosphere. Solar storms, violent eruptions of energy and particles, are dramatic reminders of the Sun's reach. When a solar storm hits Earth, our magnetosphere acts as a protective shield, diverting most of the charged particles. Without this magnetic field, life on Earth would be exposed to harmful radiation. These storms can create spectacular auroras, but also disrupt communications, satellites, and even power grids. Engineers and scientists track solar storms closely, using space weather predictions to safeguard technology. It's fascinating to think that a storm happening 93 million miles away can have such direct consequences for life on Earth. The magnetosphere isn't invincible, though. Strong solar storms can temporarily compress it or create geomagnetic disturbances. Every solar storm is a reminder of how intimately Earth is connected to its parent star. Fact 48. Historical solar storms. Solar storms aren't just modern concerns, they've been affecting Earth for centuries. One of the most famous was the Carrington event of 1859. Telegraph systems failed, sparks flew from machines, and auroras were visible as far south as the Caribbean. Scientists today estimate that a similar event could cause massive disruptions to our modern electrical and satellite systems. Other notable storms have caused radio blackouts, satellite damage, and even induced currents in power grids. Studying these historical events helps us understand the sun's behavior, predict future storms, and prepare for potential impacts. The sun may seem constant, but history proves it can surprise us in spectacular ways. Fact 49. Solar eclipses. A solar eclipse is one of the most breathtaking ways we experience the sun from Earth. During an eclipse, the moon passes between Earth and the sun, temporarily blocking its light. Total solar eclipses are especially dramatic. Day turns to twilight, stars appear, and the sun's corona becomes visible. Eclipses have been crucial for scientific discovery. During the 1919 eclipse, astronomers confirmed Einstein's theory of general relativity by observing the bending of starlight around the sun. Today, eclipses continue to fascinate both scientists and skywatchers, offering a rare glimpse of the sun's outer atmosphere in all its glory. Watching a solar eclipse reminds us how precisely the sun, moon, and Earth are aligned, and how this cosmic choreography creates moments of wonder and discovery. Fact 50. Transits of planets. Across the sun, transits occur when a planet passes directly between Earth and the sun, appearing as a tiny dot moving across the solar disk. Mercury and Venus are the only planets that can create visible transits from Earth. These events are rare and must be observed with special instruments to avoid eye damage. Historically, transits were used to measure distances in the solar system, helping astronomers calculate the scale of space long before modern technology. They're also reminders that even the smallest celestial bodies are part of the sun's immense gravitational and energetic influence. Watching a transit is like seeing the solar system's mechanics in motion, a tiny planet tracing a path dictated by the sun's gravity and light. It's science and beauty combined in a single, fleeting moment. Fact 51. History of sun observation. Humans have been fascinated by the sun for millennia. Long before modern science, people observed its movement across the sky, using it to measure time, predict seasons, and guide agriculture. Ancient civilizations recognized the sun's vital role in life, seeing it as a deity, a source of power, and a marker of cosmic order. The history of observing the sun is essentially the history of humanity trying to understand its influence. From tracking shadows with sundials to charting solar events like eclipses, early observers laid the groundwork for modern astronomy. These observations weren't just practical, they were the first steps in uncovering the secrets of our nearest star. Even today, astronomers continue this ancient tradition, using cutting-edge tools to study the sun in ever greater detail. The desire to understand the sun has been a constant thread through human history, shaping science, culture, and our understanding of the cosmos. Fact 52. Ancient civilizations and the sun. For ancient civilizations, the sun wasn't just a ball of fire, it was sacred and central to life. The Egyptians associated it with creation and the cycle of life, honoring its daily journey across the sky. The Mayans created intricate solar calendars, aligning their architecture with solstices and equinoxes. In China, solar eclipses were seen as omens, guiding rulers in their decisions. These civilizations observed patterns, built monuments, and developed myths, all based on the sun's movements. They noticed sunrises, sunsets, shadows, and seasonal changes long before telescopes existed. Their careful tracking of the sun influenced agriculture, rituals, and even social organization. The sun's importance to ancient people reminds us that science often begins with simple observation. Even without advanced technology, these early astronomers laid the foundations for understanding the star that makes life on Earth possible. Fact 53. Solar telescopes. The invention of the telescope revolutionized sun observation. Early solar telescopes allowed astronomers to safely study sunspots, solar flares, and prominences in unprecedented detail. By filtering out harmful light, these instruments revealed the sun as a dynamic, ever-changing star rather than a static, perfect disk. Solar telescopes also made it possible to measure the sun's size, track its rotation, and observe its magnetic activity. Modern versions use sophisticated optics and filters, including specialized instruments in space, to study the Sun without interference from Earth's atmosphere. Thanks to solar telescopes, our understanding of the Sun shifted from myth and speculation to precise science. They turned the Sun into a subject we can analyze, predict, and even anticipate in terms of its activity and influence on Earth. Fact 54. Sunspots discovery. Sunspots were first carefully recorded in the early 1600s by astronomers like Galileo Galilei. Before then, some crude observations existed, but telescopes allowed scientists to see that the Sun's surface wasn't perfectly smooth. It had cooler, darker regions that changed over time. The discovery of sunspots revealed that the Sun was active, with dynamic magnetic processes shaping its surface. Tracking sunspots also led to the understanding of the Sun's rotation, and eventually the 11-year sunspot cycle. This discovery was revolutionary, proving that even the Sun, seemingly eternal and unchanging, had moods and cycles. Sunspots opened a new chapter in solar science, showing that observation, careful measurement, and curiosity could reveal profound truths about our nearest star. Fact 55. Solar imaging technologies. Today, we have advanced imaging technologies that let us see the Sun in ways ancient astronomers could never imagine. Space-based instruments like the Solar Dynamics Observatory capture the Sun in multiple wavelengths, ultraviolet, X-ray, and visible light, revealing flares, coronal loops, and plasma flows. Ground-based observatories use adaptive optics and specialized filters to study sunspots and solar granules. These images help scientists track solar storms, understand magnetic fields, and even predict space weather that could affect Earth. Modern solar imaging transforms the Sun from a distant, blinding light into a dynamic, measurable, and fascinating object. It's a perfect example of how curiosity, technology, and observation combine to unlock the secrets of our star. Fact 56. Satellites studying the Sun. Studying the Sun from Earth has its limits. Our atmosphere blocks much of its radiation. That's why satellites are crucial. Space-based observatories orbit above the atmosphere, capturing solar activity in ultraviolet, X-ray, and other wavelengths invisible from the ground. Satellites like SOHO, Solar and Heliospheric Observatory, and STIO, Solar Dynamics Observatory, constantly monitor sunspots, solar flares, and coronal mass ejections. These observations help scientists predict space weather that could affect satellites, astronauts, and power grids on Earth. Satellites let us see the Sun in real time, almost as if we were floating beside it. They've revolutionized our understanding, revealing how dynamic and unpredictable our star truly is. Fact 57. Solar observatories on Earth. Even though space-based instruments are essential, Earth-based solar observatories remain valuable. Located in remote, high-altitude areas with clear skies, these telescopes use specialized filters to safely study the Sun's surface, sunspots, and prominences. Ground observatories often work in tandem with satellites, providing long-term monitoring and high-resolution imaging. Adaptive optics help correct for atmospheric distortion, allowing scientists to track small-scale solar features in remarkable detail. These observatories are a reminder that even from the ground, careful observation and technology can reveal the Sun's secrets without stepping into space. Fact 58. The Parker Solar Probe mission. Launched in 2018, NASA's Parker Solar Probe is one of humanity's boldest missions to the Sun. It travels closer than any spacecraft before, diving into the Sun's outer atmosphere, the corona, to study its heat, magnetic fields, and solar wind. The probe faces extreme heat and radiation, with a shield that can withstand temperatures over 2500 degrees or 937 Celsius. Its mission aims to answer questions about why the corona is hotter than the Sun's surface and how solar wind accelerates into space. By getting closer than ever, Parker Solar Probe is providing data that could transform our understanding of the Sun's behavior and its impact on the solar system. Fact 59. Solar Orbiter Mission. The European Space Agency's Solar Orbiter complements NASA's efforts by providing detailed images of the Sun's poles and surface. Launched in 2020, it studies solar winds, magnetic fields, and energetic particles from unique angles. Solar Orbiter captures high-resolution images and combines them with in-situ measurements, giving scientists an unprecedented view of the Sun's magnetic environment. By observing polar regions, it helps us understand the global magnetic field, which influences sunspot cycles and solar storms. Together with Parker's solar probe, the Solar Orbiter is opening a new era of solar exploration, revealing aspects of the Sun that were previously hidden from view. Fact 60. Challenges of observing the Sun safely. Observing the Sun isn't as simple as looking up. Direct exposure can permanently damage eyes. That's why specialized filters, eclipse glasses, and solar telescopes are essential. Even brief unprotected glances can cause blindness. For satellites and probes, the Sun's extreme heat and radiation pose engineering challenges. Instruments must be shielded, cooled, and designed to withstand intense energy without failing. Despite these dangers, observing the Sun safely is worth the effort. Every instrument, every mission, and every observation brings humanity closer to understanding the star that powers life, drives climate, and shapes the solar system. Fact 61. The Sun in mythology. For thousands of years, humans have looked to the Sun with awe, weaving stories and myths to explain its power. Across ancient civilizations, the Sun wasn't just a bright object in the sky. It was a force that shaped life, death, and time itself. In Egypt, people imagined the Sun traveling across the heavens every day in a golden boat, bringing light and warmth to sustain life. The Norse envisioned the Sun as a chariot pulled by horses, eternally chased by a wolf, a symbol of cycles and endings in their storytelling. These myths weren't just fanciful tales. They were humanity's first attempts to understand the life-giving energy of the Sun. Ancient people noticed its regularity, its warmth, and its ability to sustain life. They projected stories onto the Sun, giving it personality, movement, and a sense of purpose. The Sun became a central character in creation myths, daily journeys across the sky, and the eternal balance between light and darkness. Even today, mythology reminds us that the Sun has always been more than a star. It's been a symbol of energy, vitality, and the rhythm of life. Our ancestors used imagination to make sense of the universe, and their stories still inspire art, literature, and cultural thinking. Fact 62. The Sun in art and literature. Artists and writers have long been captivated by the Sun. Renaissance painters captured golden sunrises, radiant halos, and the warmth of sunlight reflecting off human figures. Poets across centuries have celebrated the Sun as a symbol of life, hope, and inspiration. Its glow represents energy, renewal, and the passage of time, a universal theme that transcends culture. In literature, the Sun is rarely just a physical object. It carries metaphorical weight. It might symbolize growth, enlightenment, or even harsh truths. A sunrise can signify a new beginning, while a scorching midday sun can represent relentless challenges. Sun imagery evokes emotion, marks transitions, and reminds readers of the passage of days, seasons, and human experience. The Sun's presence in art and literature reflects the deep emotional and symbolic connection humans have had with it for millennia. Its light has illuminated not only the Earth, but also the imagination of generations, shaping culture and creativity. Fact 63. Solar symbols. Across civilizations. Across the globe, civilizations have adopted symbols of the Sun to represent life, power, and divinity. The Egyptians used the solar disk to represent Ra, while in Mesoamerica, codices depicted the Sun as a fiery circle or a golden face. Even today, flags, logos, and emblems use radiant suns to convey energy, vitality, and strength. Solar symbols often carry deep cultural meaning, representing cycles of life, rebirth, and illumination. They link humanity to the natural rhythm of the universe, reminding us that the Sun's influence is both practical and symbolic. By embedding the Sun in art, religion, and design, societies acknowledged its central role in sustaining life and inspiring imagination. Fact 64. The Sun in calendars and timekeeping. Before clocks and modern calendars, the Sun was humanity's timekeeper. Ancient civilizations tracked its movement to mark days, months, and seasons. Stone circles, pyramids, and temples were precisely aligned with solstices and equinoxes, allowing people to plan agricultural activities and religious festivals. The Mayans, Egyptians, and other civilizations built monumental observatories to measure solar events. Even today, our calendar depends on the sun. A day is defined by Earth's rotation relative to the sun, and a year by one complete orbit around it. The sun's predictable cycle has guided human activity for millennia, from planting crops to scheduling festivals, and it continues to anchor our perception of time. Fact 65. Ancient solar worship. Worshipping the sun was central to many ancient religions. Beyond Ra, Egyptians revered Aten, the sun disk, while the Inca considered Inti their patron deity. Temples, rituals, and festivals honoured the sun as the giver of life and the guarantor of order in society. These practices weren't purely spiritual. They reflected an understanding of the sun's vital role in sustaining life. Farmers relied on sunlight to grow crops, and societies organised calendars, ceremonies, and daily routines around solar events. Solar worship demonstrates that humans recognise the sun not only as a star, but also as a force shaping culture, agriculture, and belief systems. The reverence for the sun shows that humanity has long understood its importance, not just physically, but symbolically, culturally, and spiritually. Fact 66. The sun and astrology. For thousands of years, humans have looked at the sun not just as a star, but as a guide to personality, fate, and destiny. In astrology, the sun sign is considered the core of who you are, your ego, your identity, your very essence. Ancient astrologers believed that the sun's position at your birth influenced your character traits, decisions, and even the path your life might take. Across cultures, the sun symbolized vitality, power, and leadership. In Babylon, it represented kingship. In ancient Egypt, it was a symbol of creation and life. The sun was seen as a force that could shape human lives, guide decisions, and influence events. People built temples, created charts, and mapped the skies to understand its movements and patterns. Even though modern science doesn't support astrology as a factual predictor of personality or fate, the sun's symbolic significance endures. Horoscopes, tarot readings, and other spiritual practices continue to use the sun to convey ideas of strength, renewal, and personal growth. Astrology highlights the human need to find patterns in the cosmos. The sun, ever present, serves as a constant anchor in our lives, a marker of time, and a symbol of life's energy. It reminds us that the sun has never been just a physical object in the sky. It's also a mirror of human imagination, belief, and identity. Fact 67. The sun in modern media. In modern media, the sun continues to be a powerful symbol. Films, music videos, and photography often use sunrise or sunset shots to evoke emotion, hope, melancholy, transition, or drama. Think of a movie scene where the rising sun signals a new beginning, or a vibrant sunset underscores an emotional farewell. Animated films frequently give the sun a face, turning it into a character with mood, expression, and personality. This continues a tradition of anthropomorphizing celestial bodies, a storytelling tool that dates back to ancient myths but now finds a home in digital media. Photographers use sunlight to create mood, highlight textures, and enhance storytelling. Journalists and writers use sunlight imagery to indicate time, atmosphere, or emotional context. Even in literature, poems, and songs, the sun represents life, energy, and transformation. Modern media proves that the sun's power isn't only physical, it's cultural. It shapes narratives, guides visual aesthetics, and continues a centuries-old dialogue between humanity and the star that lights our world. Fact 68. Sun-inspired festivals. Across the globe, humans celebrate the sun in festivals that mark its cycles. Summer and winter solstices, when the sun reaches its highest or lowest points, have been celebrated for millennia. Stonehenge in England is famously aligned with the sunrise on the solstice, drawing thousands of visitors who witness this ancient celestial choreography each year. In India, Makar Sankranti celebrates the sun's entry into a new zodiac sign, symbolizing harvest, prosperity, and gratitude. Ancient civilizations in Mexico, Egypt, and beyond had solar festivals honoring light, life, and growth. These celebrations were often communal, linking the cycles of the sky to agriculture, social life, and spiritual renewal. These festivals show how the sun shaped human culture, inspiring rituals that celebrated survival, life, and connection. They remind us that our calendar, traditions, and sense of time have always been intertwined with the rhythms of this star. Fact 69. The Sun. Across cultures. Nearly every culture has held the sun in deep respect and admiration. The Egyptians imagined it sailing across the sky in a golden boat, bringing life each day. The Incas viewed it as a radiant force central to agriculture and governance. In Japan, the sun was considered a vital symbol, representing continuity and guidance for rulers. These cultural representations were not just decorative, they symbolized power, protection, and life itself. Festivals, temples, and art often centered on the sun, reflecting humanity's recognition of its sustaining energy. Even today, these stories influence modern literature, films, and cultural identity, showing that reverence for the sun transcends time and geography. The sun as a symbol reminds us of the universal human instinct to personify forces that shape life. Across continents and eras, the sun has been observed, honored, and integrated into culture as a source of inspiration, guidance, and awe. Fact 70. The sun's impact on human culture. The sun has done more than sustain life. It has shaped civilizations. Agriculture depends on its cycles, allowing humans to plan crops and harvests. Calendars, timekeeping, and navigation all stem from observing its movements. Festivals, myths, and art celebrate its energy, presence, and beauty. Even in modern life, the sun continues to influence culture. Our creative works, literature, music, visual arts, draw inspiration from its warmth and light. Societies have historically used the sun to symbolize hope, power, and life. Its predictable cycles allowed humans to structure communities, develop religions, and create rituals. It reminds us that the sun isn't just a star in the sky, it's an integral part of human history, imagination, and society, connecting us to both the natural and cultural world. The sun's influence extends far beyond physics. It's woven into human identity, symbolizing life, creativity, and continuity across generations. Fact 71. How the sun drives. Weather. The sun is the ultimate engine behind Earth's weather. Its energy heats our planet unevenly, and this imbalance is what creates wind, rain, and storms. Think about it. The equator receives more sunlight than the poles, so the air above it warms, becomes lighter, and rises. Meanwhile, cooler air from the poles sinks to take its place. This constant movement sets up global circulation patterns that shape climate and weather worldwide. Local weather is influenced by the same energy on smaller scales. Sunlight warms land surfaces faster than water, which is why coastal regions often have breezy afternoons. Warm air rises, cools as it expands, and forms clouds. If conditions are right, those clouds produce rain, thunderstorms, or even snow. The sun also drives ocean currents, indirectly moving heat around the globe. The Gulf Stream, for instance, carries warm water from the tropics to Europe, moderating temperatures and affecting storms. Even the tiniest breezes trace their energy back to the sun. Every raindrop, thunderclap, or gentle wind is ultimately powered by sunlight. Imagine the sun as a giant engine 93 million miles away, invisible but constantly shaping every movement in our atmosphere. Without it, Earth would be a lifeless ball of ice. Interestingly, solar activity can also influence weather patterns. Variations in solar output, like those during the sun's 11-year cycle, may slightly impact Earth's climate, contributing to subtle changes in temperature or precipitation. Though minor compared to other climate drivers, it shows how closely connected our planet is to this star. In short, weather isn't just a local phenomenon, it's a cosmic dance between Earth and the sun. When you feel the warmth of sunlight on your skin or notice the breeze rustling leaves, you're experiencing the sun's influence firsthand. It's a reminder that the sun doesn't just give light, it orchestrates life's rhythms, moods, and movements in ways we often take for granted. Fact 72. Sunlight and seasons. Seasons exist because of Earth's tilt and the sun's angle in the sky. The planet isn't perfectly upright, it tilts about 23.5 degrees on its axis. When the northern hemisphere tilts toward the sun, it receives more direct sunlight, longer days, and warmer temperatures, resulting in summer. 6 months later, when it tilts away, days shorten, temperatures drop, and winter sets in. But sunlight affects more than just temperature. plants depend on seasonal changes to know when to sprout, flower, and bear fruit. Farmers have relied on the sun for millennia to plan planting and harvest schedules. Animals, too, sense seasonal light cues for migration, mating, and hibernation. Even humans respond subconsciously. Long, bright days often boost energy and mood, while short, dark winters can lead to seasonal affective disorder in some people. The sun's apparent movement across the sky throughout the year, higher in summer, lower in winter, is another consequence of this tilt. Ancient civilizations noticed this and created calendars based on solstices and equinoxes, using the sun as a celestial clock to organize society. Seasons are a subtle reminder that life on Earth is governed by our star. From shifting weather patterns to biological cycles, the sun's path through the sky orchestrates much of the planet's rhythm. Every seasonal change, every blossoming flower, and every migration event can be traced back to sunlight and Earth's tilt, a cosmic choreography we often take for granted. Fact 73. Solar energy on Earth. The sun isn't just a source of light and warmth, it's a vast reservoir of renewable energy. In just 1 hour, the sun delivers more energy to Earth than humanity uses in a year. This power can be captured through solar panels, which convert sunlight into electricity for homes, businesses, and even spacecraft. Beyond electricity, solar energy drives natural systems. Plants rely on sunlight for photosynthesis, forming the foundation of nearly all food chains. Ocean currents, wind patterns, and weather are powered indirectly by solar heating. Even fossil fuels buried millions of years ago originated from ancient sunlight stored in plants. The technology we use today, solar panels, solar water heaters, and photovoltaic cells, is a continuation of humanity's age-old connection to the sun. By converting sunlight into energy, we're harnessing the same force that powers weather, photosynthesis, and life itself. Solar energy is clean, sustainable, and abundant. Unlike fossil fuels, it doesn't pollute the air or deplete Earth's resources. As technology improves, solar power is becoming more efficient and accessible, offering a way to reduce greenhouse gas emissions and fight climate change. In essence, every bit of sunlight we capture is a direct link to the sun, turning natural energy into practical solutions. It's a daily reminder that our star isn't just a glowing ball in the sky. It's the engine that makes life, weather, and modern technology possible. Fact 74. Sunlight and human health. Sunlight is crucial for human health. When it touches the skin, it triggers the production of vitamin D, which helps bones absorb calcium, strengthens the immune system, and even supports mood regulation. Exposure to morning sunlight also helps regulate our circadian rhythm, telling the body when to sleep, wake, and release hormones. The benefits go beyond physiology. Sunlight can improve mood, increase alertness, and help fight seasonal affective disorder. Short walks outside or sitting near a sunny window can make a significant difference in energy levels and mental health. However, sunlight isn't without risk. Too much exposure can damage skin cells, accelerate aging, and increase the likelihood of skin cancer. Balancing the benefits and risks of sunlight is essential for living healthy lives, which is why protective measures like sunscreen, clothing, and shade are so important. Humans have always depended on sunlight, not just for energy, but for health and psychological well-being. It's a reminder that our connection to the sun is personal, physical, and deeply embedded in our daily routines. Fact 75. Sunburn and UV exposure. Sunburn is a visible and painful reminder of sunlight's power. It occurs when ultraviolet, UV rays damage the DNA in skin cells. Even short exposure can cause redness, pain, and long-term harm, while repeated exposure increases the risk of skin cancer. UV rays are invisible, which makes them easy to underestimate. Clouds only partially block UV radiation, so even on overcast days, protection is necessary. Sunscreen, hats, and protective clothing are essential tools to enjoy sunlight safely. Sunburn highlights the delicate balance between benefiting from sunlight and respecting its power. While sunlight supports life, energy, and mood, it's also intense and potentially dangerous. Understanding how to navigate this balance is part of humanity's ongoing relationship with our star. The sun is generous, but it also demands respect. By appreciating its benefits and protecting ourselves from its harm, we can fully enjoy the gift of sunlight while staying safe, a daily lesson from the star that powers our world. Fact 76. Vitamin D from sunlight. One of the most vital gifts the sun gives us is vitamin D. When sunlight touches our skin, it triggers a chemical reaction that produces this essential nutrient. Vitamin D helps our bodies absorb calcium, strengthening bones, teeth, and muscles. It also supports immune function and plays a role in mood regulation. Humans have evolved to rely on sunlight for vitamin D, which is why regions with less sunlight sometimes see higher rates of deficiency. Just 10-30 minutes of sunlight a few times a week can provide enough for most people, depending on skin type and location. While vitamin D is crucial, moderation is key. Too much sun increases the risk of skin damage and cancer, so balancing exposure while benefiting from this natural nutrient is an essential part of human health. Fact 77. The sun and ocean currents. The sun doesn't just heat the land, it drives the oceans too. Solar energy warms the surface of the seas, creating temperature differences that influence ocean currents. Warm water near the equator rises and flows toward the poles, while cold water sinks and returns toward the equator, forming global circulation patterns. These currents distribute heat around the planet, affecting weather, climate, and marine ecosystems. The Gulf Stream, for instance, brings warm water from the tropics to Europe, moderating its climate. Without the sun's energy driving these movements, Earth's climate would be far less stable, and marine life would struggle to thrive. The sun is a silent but powerful force behind the movement of the oceans, showing its influence extends far beyond the skies. Fact 78. The sun and climate change. The sun has long influenced Earth's climate, but today, human activities amplify changes. Solar radiation affects temperature, wind patterns, and precipitation. Over centuries, natural variations in solar output have caused warming and cooling periods. While the sun's energy contributes to climate cycles, scientists agree that current rapid climate change is driven mainly by greenhouse gases, not solar variations. Nevertheless, understanding the sun's role helps climate scientists differentiate between natural and human-induced factors, improving predictions and solutions. The sun is both a contributor to natural climate rhythms and a reminder that our planet's energy balance is delicate, requiring careful study and stewardship. Fact 79. Solar power as renewable energy. Solar power is a modern way to harness the sun's energy for electricity. Solar panels convert sunlight into electricity using photovoltaic cells, offering a clean and renewable alternative to fossil fuels. Cities, homes, and even spacecraft rely on solar energy to power daily life. Beyond electricity, solar heating and solar farms provide sustainable energy solutions worldwide. The sun delivers more energy to Earth in 1 hour than humanity uses in a year, making it an almost limitless source if we continue improving technology to capture it efficiently. Solar power isn't just convenient, it's a direct connection to the sun, turning natural energy into practical solutions for modern life. Fact 80. Future of solar technology. The future of solar technology is bright, literally. Innovations like flexible solar panels, solar windows, and space-based solar power could dramatically increase efficiency and accessibility. Researchers are exploring ways to store solar energy longer and convert it more efficiently into electricity and heat. Emerging technologies may one day power entire cities using the sun's rays or provide electricity in remote areas without relying on traditional grids. The sun will continue to be both a source of inspiration and a practical solution to energy challenges. As technology evolves, our relationship with the sun moves from admiration to active partnership, using its energy responsibly to sustain life and power our world. Fact 81. The sun's rotation speed. The sun isn't a solid object, so it doesn't rotate like Earth does. Instead, it rotates at different speeds depending on latitude, a phenomenon called differential rotation. Near the equator, the sun completes one rotation in about 25 days, while near the poles, it takes roughly 35 days. This uneven rotation stretches and twists the sun's magnetic field lines, which contributes to the formation of sunspots, solar flares, and prominences. The twisting also powers the solar dynamo, the process that generates the sun's magnetic field. The sun's rotation might seem slow compared to Earth's 24-hour day, but considering it's a gigantic sphere of hot plasma more than 1,000,000 kilometers in diameter, its motion is astonishing. Understanding rotation is crucial for predicting solar activity and space weather, which can impact satellites, communications, and power systems on Earth. In a sense, the Sun's rotation is like the heartbeat of our star, constant, dynamic, and shaping everything from magnetic storms to the patterns of sunspots we see across its surface. Fact 82. The Sun's magnetic field strength. The Sun's magnetic field is immensely powerful. While Earth's magnetic field measures around 0.25 to 0.65 Gauss, the Sun's average surface magnetic field is about 1 Gauss. But in sunspots, this can spike to thousands of Gauss, intense enough to drive massive solar flares and coronal mass ejections. The magnetic field is responsible for almost all solar phenomena we observe: the looping prominences, the swirling sunspots, and the release of charged particles into space. It's created by the movement of hot plasma in the Sun's interior, generating electric currents that create magnetic lines of force. The Sun's magnetism doesn't just affect the star itself, it extends throughout the solar system via the solar wind, shaping planetary magnetospheres and influencing space weather. Our modern technology is closely tied to understanding this invisible force, because a strong magnetic storm can disrupt satellites, navigation, and power grids on Earth. The Sun's magnetic field reminds us that its influence is not just light and heat, but a complex invisible force that shapes life across the solar system. Fact 83. Largest recorded sunspots. Sunspots may look small through a telescope, but some are enormous, thousands of kilometers across. The largest recorded sunspot observed in 1947 was over 120,000 kilometers wide, large enough to fit 10 Earths across its diameter. These massive spots are cooler regions on the Sun's surface caused by concentrated magnetic fields. They appear dark because they are cooler than surrounding plasma, but don't be fooled. Cooler still means around 3,500 Dalmsdrum, 6,300 Dalmdom. Giant sunspots often precede powerful solar flares, releasing energy equivalent to millions of nuclear bombs. Studying huge sunspots helps scientists understand the Sun's magnetic behavior, predict space weather, and learn how solar storms might impact Earth. They're a striking example of how immense and powerful our nearest star truly is. Fact 84. Solar flares' energy. Output. Solar flares are sudden bursts of energy on the Sun's surface, releasing enormous amounts of radiation and charged particles. A single large flare can emit energy equivalent to billions of nuclear bombs detonating at once, all in a matter of minutes. Flares occur when twisted magnetic field lines snap, releasing stored energy into space. This energy travels toward Earth as electromagnetic radiation and charged particles, potentially causing radio blackouts, satellite disruptions, and auroras. While dangerous for technology, solar flares are fascinating natural phenomena. They demonstrate the immense power of the Sun and remind us that our seemingly steady star can release sudden, extreme bursts of energy that ripple across the solar system. Fact 85. Fastest solar wind speeds. The Sun constantly emits streams of charged particles known as the solar wind. These particles travel at incredible speeds, ranging from 400 to 800 kilometers per second on average, but some can reach speeds of up to 2,000 kilometers per second during intense solar events. Fast solar winds originate in coronal holes, where magnetic field lines open into space. When these winds reach Earth, they interact with our magnetosphere, producing auroras and sometimes geomagnetic storms. Solar wind shapes the entire solar system, influencing planetary atmospheres, comet tails, and the interplanetary magnetic field. It's a constant reminder that the Sun's influence extends far beyond light and heat. The solar wind literally streams life-altering energy across millions of miles of space. Fact 86. Coronal mass ejection power. Coronal mass ejections, or CMEs, are among the Sun's most spectacular and powerful events. Imagine billions of tons of hot plasma and magnetic energy being hurled into space at millions of kilometers per hour. This is a CME. These eruptions can release more energy than 1 billion nuclear bombs detonating simultaneously. CMEs often follow intense solar flares and are caused by the sudden reconfiguration of magnetic fields in the Sun's corona. When directed toward Earth, they can trigger geomagnetic storms, producing dazzling auroras but also potentially disrupting satellites, communication systems, and even power grids. Studying CMEs is critical because they illustrate the sun's raw power. These events remind us that while the sun is life-giving, it can also send bursts of energy capable of affecting life and technology across the solar system. Fact 87. Solar storms' impact on satellites. Solar storms, fueled by flares and CMEs, are a constant threat to satellites orbiting Earth. Charged particles from these storms can interfere with the electronic circuits, degrade solar panels, and even temporarily disable satellites. GPS signals, weather monitoring, and communications can all be affected. The impact isn't just hypothetical. Historical events, like the 1989 Quebec blackout, were linked to geomagnetic storms caused by solar activity. Engineers designed satellites with shielding and backup systems, but strong solar storms still pose challenges. Understanding the sun's behavior helps protect our technology. Solar storms remind us that our dependence on space-based systems ties us directly to the moods and outbursts of a star 93 million miles away. Fact 88. Past mass extinctions and solar activity. When we think about mass extinctions on Earth, we often imagine catastrophic events like asteroid impacts, massive volcanic eruptions, or sudden climate shifts. But did you know that the sun, our constant life-giving star, may have played a subtle yet fascinating role in these events too? While the sun isn't considered the primary driver of mass extinctions, its activity over millions of years could have nudged Earth's environment in ways that made life more vulnerable at critical moments. The sun's energy output isn't perfectly constant. Over long timescales, it experiences variations in radiation levels, including small but significant fluctuations that can affect Earth's climate. During periods of reduced solar output, for instance, Earth may have experienced cooler temperatures, shorter growing seasons, or shifts in ocean currents. Conversely, periods of high solar activity could increase radiation levels reaching the surface, especially when combined with disruptions in the ozone layer. Both extremes would have stressed ecosystems that were already facing other natural challenges, potentially tipping the balance toward extinction for sensitive species. Solar storms, intense bursts of energy, and charged particles from the sun are another piece of the puzzle. While most solar storms today are largely harmless thanks to Earth's protective magnetosphere, ancient Earth might have been more exposed during periods of weaker magnetic shielding, or when extreme solar events coincided with other environmental stresses. Increased radiation from these storms could have impacted life directly, damaging DNA or reducing populations of vulnerable organisms. Over thousands or millions of years, such repeated solar influences could subtly shape evolutionary trajectories, even if they didn't trigger mass die-offs on their own. Modern scientists study these ancient influences using a variety of methods. Ice cores from glaciers, tree rings, and isotopic records provide clues about past solar activity. Certain isotopes, like carbon-14 or beryllium-10, are produced in the atmosphere when cosmic rays interact with solar magnetic fields. By examining their abundance in ancient layers, researchers can reconstruct patterns of solar intensity and correlate them with periods of climate change or ecological stress. This allows us to see connections between subtle shifts in the sun's behavior and major environmental changes on Earth. What's truly fascinating is thinking about how a star 93 million miles away might have quietly influenced the course of life here. The sun, while overwhelmingly life-sustaining, isn't perfectly gentle. Its fluctuations may have created additional stress for ecosystems already coping with other natural challenges. In some cases, these solar influences may have nudged species closer to extinction or contributed to conditions that made recovery slower and more difficult. Ultimately, studying the sun's role in past mass extinctions reminds us that Earth's history is not shaped by a single factor, but by a complex interplay of forces, both terrestrial and cosmic. It also gives perspective on the delicate balance of life today. The same star that powers our world can, under certain conditions, become a subtle agent of change, sometimes for better, sometimes for worse. The sun's influence on life is vast, intricate, and awe-inspiring, extending far beyond the warmth and light we feel every day. Fact 89. The sun's eventual red giant phase. It's almost impossible to imagine, but our sun, a constant presence in our sky, will not shine forever. In about 5 billion years, the Sun will run out of hydrogen in its core, the fuel that powers its nuclear fusion. Without this steady supply of hydrogen, the core will contract while the outer layers expand enormously. This is the beginning of the Sun's red giant phase, one of the most dramatic transformations a star can undergo. During this stage, the Sun's surface will become cooler, giving it a reddish appearance, but its sheer size and brightness will dwarf what we see today. Its outer layers will swell outward, potentially engulfing Mercury and Venus. Some models even suggest Earth may be swallowed, or, at the very least, scorched beyond habitability. The planets that survive will face a completely altered solar system, with changed orbits and a dramatically brighter, larger sun in the sky. This expansion is not sudden. It will occur gradually over millions of years, giving the solar system plenty of time to adjust. Yet the scale is staggering. Imagine the Sun so large that it fills the sky as a giant red disk, dwarfing anything else we've ever known. Our familiar night sky would vanish under constant reddish daylight, and life on Earth, as we know it, would be impossible. Studying distant red giants in our galaxy helps astronomers visualize this future. By observing these stars, scientists learn how hydrogen exhaustion, core contraction, and outer expansion unfold. Each red giant we see today is a glimpse into the distant future of our own Sun, a preview of the immense forces that will eventually reshape our solar system. The red giant phase is a natural part of stellar evolution. Even stars that seem eternal eventually exhaust their fuel and change in ways that ripple across the planets orbiting them. It's humbling to realize that the very star that nurtures life on Earth today will one day transform into a colossal, life-erasing giant. And yet, this cosmic inevitability is part of the cycle of the universe: creation, transformation, and eventually rebirth in new forms. Thinking about this future gives perspective on the Sun's current stability. Today we enjoy its warmth, energy, and life-giving light, but in the grand scheme of billions of years, even our most familiar star is temporary. The red giant phase reminds us of the fragile, fleeting balance that allows life on Earth to exist, and how small our window in cosmic time really is. Fact 90. Predicted end of the Sun. After the Sun finishes its red giant stage, the next chapter in its life is equally fascinating. Once the outer layers have expanded and then drifted away, they form a glowing shell of gas known as a planetary nebula. This colourful, ethereal cloud will drift into space, a final farewell display from the star that sustained life for billions of years. At the centre of this nebula will remain the Sun's core, now a white dwarf. This compact remnant is roughly the size of Earth, but contains about half the Sun's mass. It no longer produces energy through fusion, but instead slowly radiates the heat stored during its lifetime. For a while, it will shine dimly, a small but dense star marking the end of its active life. Over trillions of years, the white dwarf will cool, fading ever more until it becomes a cold, dark remnant, essentially a cosmic cinder. Though this is unimaginably distant in time, the process is inevitable. Stars like our Sun are not eternal. Even something as constant and essential as the Sun follows the universal rules of stellar life cycles. Understanding the Sun's ultimate fate isn't just academic. It frames how we think about time, existence, and the fragile conditions that allow life to thrive today. The warmth, light, and energy we take for granted are temporary, a reminder of how extraordinary the current balance of our solar system truly is. It also inspires a sense of humility. Humanity lives on a planet orbiting a star that will one day fade away, leaving the cosmos forever changed. In the end, the Sun's life story is a narrative of transformation, from a glowing main sequence star to a giant, then a planetary nebula, and finally a quiet white dwarf. While the timeline stretches billions of years into the future, it reminds us that the universe is dynamic and ever-changing. Our Sun, the ultimate source of life on Earth, will eventually take its place among the countless stars that have lived and died in the vast cosmic tapestry. Fact 91. The Sun's light. Takes 8 minutes to reach Earth. Every time you feel the warmth of the Sun on your skin, you're interacting with energy that began its journey millions of kilometers away. Light travels incredibly fast, roughly 299,192 kilometers per second. But even at that speed, sunlight takes about 8 minutes and 20 seconds to reach Earth. That means the golden rays falling on you right now actually left the sun 8 minutes ago. In a way, looking at the sun is like peeking slightly into its past. This delay isn't just a fun fact, it's central to how we study solar activity. When astronomers observe a flare, sunspot eruption, or a coronal mass ejection, the light reaching their telescopes is already 8 minutes old. The sun's surface might have changed in that fraction of time, but we still see the snapshot from the moment the light left. Even though 8 minutes sounds short, in terms of energy travelling across nearly 150 million kilometres, it's a humbling reminder of the vast distances in space. Thinking about that journey gives perspective. Every photon racing toward Earth has spent years bouncing inside the sun's core, slowly making its way out through the radiative and convective zones before finally escaping into space. The sunlight we take for granted is the end product of nuclear reactions that started deep inside the star over millions of years. Those 8 minutes of travel are just the final step in an unimaginably long journey. It's incredible to realize that our entire daily experience, morning warmth, noonday heat, evening light, depends on this constant flow of energy across space. That invisible thread linking Earth to the heart of the sun reminds us that we exist in a connected system, with life sustained by events happening millions of kilometers away. It also explains why we can't feel immediate effects from the sun's surface changes. The light carries a slight delay, making every moment of sunlight a tiny glimpse into the star's recent past. So next time you step outside, pause for a moment. The light warming your skin, casting shadows on the ground, and fueling life around you is already 8 minutes old. The sun's energy isn't instantaneous. It's a patient, persistent messenger travelling across space, keeping our planet alive and vibrant in ways we rarely notice. Fact 92. Sunsets appear red due to scattering. Sunsets and sunrises have a magical quality, turning the sky into fiery reds, oranges, and pinks. It feels poetic, almost mystical, but the phenomenon has a scientific explanation called Rayleigh scattering. When sunlight passes through the atmosphere, shorter wavelengths like blue and violet scatter more easily than longer red wavelengths. This scattering is why the sky appears blue during the day. At sunset, sunlight travels through a thicker slice of the atmosphere. The longer journey scatters away most of the blue and green light, leaving red, orange, and pink hues to reach our eyes. What we see as breathtaking beauty is physics at work, the interaction of photons with air molecules and tiny particles suspended in the atmosphere. These colours aren't just pretty. They remind us that Earth's atmosphere plays a starring role in shaping how we experience our star. Clouds, pollution, and humidity can all amplify or soften the effect, creating a unique show every evening. No two sunsets are identical, because the sun's light is filtered through constantly changing atmospheric conditions. Sunsets also give us insight into Earth's connection to the sun. They mark the angle at which sunlight strikes our planet, the thickness of the air it must travel through, and the complex interactions between light and matter. Each fiery horizon is a visible reminder that the sun's energy doesn't just illuminate, it interacts with our world in subtle, mesmerizing ways. So when you pause to watch a sunset, remember, it's not magic, it's physics, dancing in the sky. The same sun that drives weather, fuels plants, and warms our skin is also painting evening masterpieces, reminding us that life on Earth is intertwined with a star millions of kilometers away. Fact 93. Solar neutrinos and their mystery. Deep inside the sun, nuclear fusion transforms hydrogen into helium, releasing enormous amounts of energy. But that's not all. Fusion also produces tiny, nearly invisible particles called neutrinos. These ghost particles are fascinating because they pass through almost everything without interacting. Not Earth, not your body, not even solid rock can stop them. For decades, scientists detected far fewer neutrinos than theoretical models predicted. This discrepancy, known as the solar neutrino problem, puzzled astronomers and particle physicists alike. It wasn't until the discovery that neutrinos can change type, or flavor, during their journey from the sun to Earth that the mystery was solved. This revelation not only confirmed our understanding of the sun's core, but also opened new doors in particle physics. Neutrinos are remarkable messengers because they escape the sun's core almost instantly, unlike photons that can take millions of years to reach the surface. Each neutrino carries direct information about the nuclear reactions powering our star. By studying them, scientists can peer inside the sun in ways that no telescope or satellite could ever achieve. In essence, neutrinos are the sun's secret whispers, travelling 93 million miles to tell us what's happening at its heart. They remind us that our star is more than a glowing ball of light. It's a nuclear powerhouse, with processes that shape the very existence of life on Earth. Fact 94. The sun's influence on human mood. The sun doesn't just shape the physical world, it touches our minds and emotions too. Sunlight regulates our circadian rhythms, signalling when it's time to wake up, eat or sleep. Without adequate sunlight, people can develop seasonal affective disorder, SAD, a depression triggered by long dark winters. Exposure to sunlight also triggers serotonin production in the brain. This neurotransmitter enhances mood, sharpens focus, and fosters a sense of well-being. Even a short walk outside on a sunny day can lift spirits, energize the body, and improve cognitive performance. Sunlight is subtle but powerful, synchronizing our internal clocks and influencing our emotional health. Historically, humans have instinctively recognized this connection. Festivals, rituals, and daily routines often revolve around sunlight, celebrating its life-giving and mood-enhancing effects. Modern science confirms what ancient civilizations sensed. The sun is a regulator, not just of climate and crops, but of human psychology as well. Fact 95. Sunspots can be larger than Earth. Sunspots might look like small dark dots through a telescope, but some are truly colossal. The largest recorded sunspots have spanned over 10 times the diameter of Earth, stretching hundreds of thousands of kilometers across the sun's surface. These cooler regions form where intense magnetic fields suppress the normal flow of heat from the sun's interior. Sunspots aren't just fascinating to look at, they signal solar activity. Large sunspots often precede solar flares and coronal mass ejections, which can influence space weather, satellites, and even power grids on Earth. Looking at a sunspot of this magnitude puts the scale of our planet into perspective. Earth could fit comfortably inside a single sunspot with room to spare. Sunspots remind us that the sun is far from static. It is dynamic, magnetic, and constantly evolving, with immense forces shaping the space around it. Observing these giant features teaches us how a star can be both nurturing and volatile, a reminder of the incredible scale and energy at play in our solar system. Fact 96. The sun's colour is actually white. We've all been taught to think of the sun as yellow, or maybe even orange or red when it rises or sets. But the sun's true colour is actually white. If you were floating in the vacuum of space, without Earth's atmosphere to scatter its light, the sun would shine as a brilliant, dazzling white sphere, perfectly balanced across all visible wavelengths. The colours we see from Earth are a trick of our atmosphere. Shorter blue wavelengths scatter more easily than longer red ones. That's why the sky appears blue during the day. At sunrise or sunset, sunlight travels through a thicker slice of atmosphere, scattering even more blue and green light, and leaving the warm red and orange hues that paint the horizon. These moments are beautiful, but they don't reflect the sun's actual hue. Knowing the sun's true colour helps astronomers measure its temperature and classify it as a G-type main sequence star. White light contains all visible wavelengths, which is why a prism can split sunlight into a full rainbow of colours. This white light isn't just pretty, it's the engine driving life on Earth. Every plant, every ocean current, every breath of wind owes its energy to this perfectly balanced spectrum. So, next time you watch a sunset or marvel at the sun's golden glow, remember, it's a colourful performance put on by Earth's atmosphere. The sun itself shines in pure white brilliance, quietly powering life and keeping our planet alive. Fact 97. How we could ride solar wind, science fiction concept. Imagine sailing through space without fuel, powered entirely by the sun. It sounds like science fiction, but solar sails make it a tantalizing possibility. These enormous reflective sails catch particles and photons from the sun, allowing spacecraft to ride the solar wind, much like a boat glides across water with the wind in its sails. The concept works gradually. Each photon from the sun exerts a tiny push, but over time that steady pressure accelerates a spacecraft to remarkable speeds. This method of propulsion is perfect for long-distance exploration, where traditional fuel would be too heavy or limiting. The Japanese Icaros mission has already successfully tested solar sail technology, proving the idea isn't just imagination, it's real science. Riding the solar wind is more than transportation, it's a way to connect with our star in a direct physical sense. It's humanity harnessing the energy that has shaped life, weather, and technology on Earth for billions of years, now to explore other worlds. This futuristic dream captures both the ingenuity and audacity of humans, turning the sun's constant outflow into a cosmic vehicle. Fact 98. The Sun in Space. Exploration. Missions. For decades, the Sun has been at the center of scientific exploration. Early satellites like SOHO, Solar and Heliospheric Observatory, and SDO, Solar Dynamics Observatory, have monitored solar flares, coronal mass ejections, and magnetic fields. Daring missions like NASA's Parker Solar Probe dive closer than any human-made object before, braving extreme heat and radiation to gather data. These missions do more than satisfy curiosity, they protect us. Solar storms can damage satellites, interfere with communications, and disrupt power grids. Understanding the Sun helps us anticipate these events, shielding technology and astronauts from potential danger. Every measurement, every image, is like reading the Sun's diary. Each flare, each particle stream tells a story of how this star works, how it influences planets, and how humans might safely harness its energy. Space exploration missions remind us that the Sun is not just a distant ball of light, it's a dynamic force with direct consequences for life and civilization. Fact 99. How Earth protects us from harmful rays. The Sun is generous with energy, but not all of it is safe. Ultraviolet UV rays can damage DNA, cause sunburn, and increase cancer risk. X-rays and other high-energy radiation could be deadly if they reached Earth's surface unfiltered. Luckily, our planet has two incredible shields. The atmosphere, especially the ozone layer, absorbs much of the harmful UV radiation. The magnetic field forms the magnetosphere, deflecting charged particles from solar winds. Together, these systems create a protective bubble, allowing life to thrive under sunlight's gentle warmth. Earth's defenses are a reminder that the Sun demands respect. It gives energy and sustenance, but without careful balance, that same energy could be destructive. Life exists because our planet both receives sunlight and protects itself from its dangerous extremes. Fact 100. The Sun as our ultimate energy source. Every bit of energy on Earth traces back to the Sun. Plants capture its light through photosynthesis, forming the foundation of all food chains. Wind, water currents, and fossil fuels all derive from solar energy stored or redistributed. Even the warmth on your skin comes from our star's relentless energy output. Modern humans harness this energy directly, using solar panels to produce clean, renewable electricity. The Sun provides vast, sustainable energy that will outlast human civilization if used wisely. Its light drives weather, sustains ecosystems, and fuels imagination. From cultural myths to modern technology, the Sun is far more than a star in the sky. It is the engine of life, the pulse of Earth's systems, and the guiding light for our future. Every day it reminds us of our connection to the cosmos and the immense power of a single star. The Sun isn't just a ball of light in the sky. It's a dynamic, powerful force that shapes everything on Earth, from weather and seasons to life itself. Its mysteries, from solar storms to its eventual fate, remind us how connected we are to this blazing star. Every sunrise and sunset carries stories billions of years in the making. Now that you've discovered 100 fascinating facts about the Sun, which one surprised you the most? Drop your thoughts in the comments and share this journey with friends who love the wonders of space. And don't forget to hit like and subscribe. There's so much more of the universe to explore together.